move on to my topic, which is a bit more boring than what she went through. It's about data collection, database building, and statistical analysis. So basically, let's think of the story of the 6 blind men and the elephant. The one who touched the tail of the elephant thought it was like a rope. The one who touched the trunk thought it was like a wall. The one who touched the feet thought it was like the trunk of a tree, and so on and so forth. So without collecting data properly, analyzing the same, we will all be left like the 6 blind men. So therefore, why do we analyze data? To obtain useful and usable information, to describe and summarize the data, to identify relationships between variables and examine their statistical significance, compare and find differences between the various variables, and forecast the outcomes. So now we go on to getting our data ready. If we are looking at a large database, then we should assign a unique identifier. Organize and keep all the forms, the questionnaires, the interviews and testimonials in order. Even if we are entering data directly onto the computer, then in today's world, keeping the consent forms properly is of utmost importance. Check for completeness and accuracy, and remove the data that are incomplete or do not make sense. So data entry. Of course, we can go back to the prehistoric time and do everything on pen and paper, but nowadays we do it using a large number of software. Like for example, the most commonly we use Excel spreadsheets. The Microsoft Access is more of a professional's forte. It helps in the database management when you are looking at a huge number of data. For quantitative analysis, we can use Excel, and of course we can use SPSS. And for qualitative data, we have software like AIOC2020, in vivo. Like for example, when we are looking at AIOC2020, qualitative data, suppose we are quantifying anything on a Likert scale, or say marking anything between 0 to 10. Now using this AIOC2020, we can actually do a Reddit analysis, get a result, and depending on that, we can actually tell what is the significance. Now the softwares like NVivo out there, suppose we are looking at some descriptive terms. Like for example, say, will the widening of a road, how will it affect the movement of traffic? So here we ask the patients, here we ask the people direct questions. And if we feed the answers onto the NVivo, then what it does is it searches for the commonly used terms, and based on that, it can give you an output. Like if you widen the road, there will be less congestion, so on and so forth. Now, normally, when we put in data into Excel, this is what the situation looks like. For each workbook that we have opened, we can just right-click on this, and we can actually, rename the workbook so that we can actually, whenever we are going back to our data, we know what exactly we are dealing with. The same thing can be done on SPSS as well. In the SPSS, however, you have two things. One is the data view, and the second one is the variable view. Now, you see that all these headings in the data view, we have all the data. Now, when we go on to the variable view in SPSS, we can find out, like for example, the first column was serial, whether it is a numeric or a string, what are the number of decibels, and so on and so forth. So these are all the things that we get under the variable view. Now going on to the analyzing the data and interpreting the same. As Dr. Anuradha emphasized, we have to think about the analysis early. It is not that we keep on collecting data, analyze, and finally we look at our results and say, oh God, we have left so many things behind. So start with a plan. It is very good actually to do a pilot study. Like for example, when we did the Hooghly River glaucoma study under Dr. Chandrima Paul, we first did a small pilot study. And there we could actually find out which parameters were actually we were able to remove a few redundant parameters. Like these would not make be a part of the study, and then we could make the study more comprehensive, more focused. So it is always good to have a pilot study. We should code, enter the data properly, and there should be a cleaning up of the data also. Redundant data, data which seems not to make much sense, should be cleaned. Analyzing. Now this analysis should never be at the final step. It should be a continuous process. Say after every 300 or 400 data entry, we should be able to analyze what is happening so that we are moving forward properly, interpreting the data and reflecting upon the results that we are getting. Like, what did we learn? What conclusions can we draw? What are our recommendations? And what are the limitations of our analysis? So once again, if we look at the key components of a data analysis plan, so as we have discussed, so first is developing the questionnaire design, reflecting on the research design, collection of the data, tabulation of the same, and now we come on to the analysis of the data. So the key components are, what are the purpose of the evaluation, the questions that we have asked, what you hope to learn from the question, the technique of analysis, and how data will be presented. These are so important. Now the common descriptive statistics that we come across in most of the studies include the frequency, the median, mode, range, standard deviation, variance, and of course the statistical significance. Now if you look at this particular, if you look at the bar here, if you right click on this bar, you can actually include or exclude any particular value that you do not want Excel to show. So out here, I needed the count, I needed the average. So if you select any column, like for example, here I have selected the central corneal thickness, I can straight away have a look at the count. We have 193 entries here, and we can look at the average CCT of these 193 entries. So this way, when we are looking at the analysis every fortnight or every month, or say after 200 or 300 data entries, we can know that whether the data that we have analyzed is getting skewed or not. If it is getting skewed, then definitely we'll have to go back, look at our inclusion criteria, and so on and so forth. The same can be done in SPSS as well. If you click on the analyze, the descriptive statistics, and you have whole lot of these things. If you press on the frequencies, you actually get all the values in SPSS very easily. I'll just touch upon the normal distribution curve. As we all know, it is a bell-shaped symmetric curve. The mean and the standard deviation. The mean is denoted by mu, the standard deviation by sigma. So approximately 50% of the values will fall above and below the mean. Approximately 68% of the values fall within one standard deviation. 95% of the values will fall within 2 standard deviation of the mean, and 99.7% of the values will fall within 3 standard deviation. So if we look at the results, most of the time what we find, say the central corneal thickness is 530 microns plus minus 7 microns. Well, that plus minus basically denotes 1 standard deviation on either side. So if the value is 537 plus minus 7 microns, it simply means that between 530 and 544 microns, the 68% patients will fall within that. So plus minus 1 standard deviation is what we normally denote. However, if we want our result to be more inclusive, then of course we can put 2 standard or 3 standard deviations, but normally the norm is to put the mean plus minus 1 standard deviation. Once again, standard deviation can be very easily calculated using Microsoft Excel. So basically the statistical, and then we have the stdev.p, and then we just get the statistical analysis, the regression statistics, ANOVA, everything will be given by the software itself. It's as easy in SPSS also. We get all the data in front of us. Now let's go on to significance testing. So basically it's also called hypothesis testing. The objective is to test a claim about a certain parameter. So here comes the concept of the null hypothesis. The null hypothesis essentially means that there is suppose we want to compare the central corneal thickness in a rural and an urban population. We start with the null hypothesis, which states that there is no difference between the CCT values in the two, and HA is the alternate hypothesis, which tries to refute the null hypothesis. So basically, the null hypothesis claims that there is no difference. Alternate hypothesis contradicts the null. So how do we go about it? Well, basically, we collect the data, quantify the extent to which data provides evidence against the null hypothesis. We also need to look at the type 1 and the type 2 errors. The type 2 error or the false negative error is of particular significance because the power of the study we get through the type 2 error is also called the beta error, and the power of the study is 1 minus beta. And whenever we are doing a particular study, we have to make sure that the power is between 80% and 90%. And the p-value, well, as we all know, the smaller the p-value, the stronger and stronger evidence against H0 or the null hypothesis. P less than 0.05 is statistically significant. If we have to say it's highly significant, it has to be less than 0.01. So we can do that easily through Excel as well as SPSS. Sample size calculation will be dealt later. Now, expressing the results, make it very simple and very appealing. You can use bar diagrams, you can use scatter plots, you can use pie charts. So, well, basically, to combat the data deluge, we basically have to plan early, organize our data, and then go ahead and interpret the data at every result so that the final interpretation makes sense and exactly what we want. And I take this opportunity to invite all of you to AIOC 2021 at Kolkata. Thank you.